I, in the last couple of weeks, I have been preparing for the OCI Data Science certification. Now, it started because I have been learning about a lot more about AI and ML and doing a bunch of things for the past few months, including getting certifications, etc. So it was at the back of my mind that I want to understand how things work under the hood. Um, Had a look at the coursework, decided that well, there are a bunch of topics that I want to get exposure to, and they seem like I can. Once I understand those topics, I'll be able to use them across various clouds and across various architectures, etc. And one of my goals was to get hands-on exposure to end-to-end ML lifecycle. So I prepared for the exam and took the exam and I failed. Now, since then, I have reflected upon what I could have done differently and so on, but that was that. And now I just wanted to put my thoughts together um, about the coursework and what I learned so that it can provide some value to anyone who watches this video, including future me. The coursework started with again bunch of history about like machine learning, etc. Leads to OCI data science specifically. Now, very broadly, they started with like a whole bunch of diagrams about various layers. So starting with the foundational layer where there's infrastructure, your compute, CPUs, GPUs, etc. And then there is management layer, which had DBs, data lakes, and other sort of data stores that you would generally need some sort of access before you can do anything with your data. They had three pretty simple principles, and it felt like they were trying to live by, at least they were trying to build the services by those principles. So one was accelerated, one was collaborative, and another one was enterprise grade. Now, accelerated, they did provide a lot of automation tools, a lot of workflows, plethora of open source libraries were in use one way or another, and they mostly had a consistent approach to building models. In terms of the collaboration, their notebook sessions were really interesting. It used Jupyter Lab interface, which a lot of data science people are usually aware of. And the integration they had with a range of other services that made sense. Then there was also Oracle Open Data, which gave you access to large public databases, similar to other cloud providers. Features were interesting. They actually look like they have thought about what the workflow should look like from an ML perspective. And then based on that, they decided to build various services and integrated and created new features, etc. So a lot of this might sound gibberish to you, but it's so things such as projects, notebook sessions, Conda environment, and their own specific SDK, which they named Accelerated Data Science SDK. It was actually pretty powerful SDK. I'll try to touch a little more later so that I don't forget the rest of the context in my head. Then just the usual things that you have to do as an ML data science person. So like your model catalog, deployments, jobs, etc. So a lot of that kind of made a lot of sense once I had seen how things work end to end. Um, Then there was the capability or the scripting of services. This was accessible via console, API, CLI, and SDK, of course. SDK, like I said, it was fairly powerful. seemed like you could perform pretty much everything using that, ranging from accessing various data stores, data visualization, feature engineering, and model training, evaluation, deployments, etc. It was all covered using that, and in at least based on my limited exposure, it seemed fairly powerful. Tenancy configuration that you need to get these things working, that was also interesting. So OCI Science has this concept of dynamic groups. So you basically it differs from your user groups, like it can house various resources, which then can act as a principal for accessing other APIs and other resources. So you don't have to get like API keys and all. If you set up the right permissions for these, and if you have on the other side, you have the right permission sets, then these resources will be able to access those services. Oracle Resource Manager, this seems pretty similar to what Azure has. It's like a couple of times I kind of felt like this glimpses of Azure or so they have these templates that you can use to create stacks. I think, did I mention that before? So pretty much making things easy with the mostly same defaults, but depending on how complex your environment is and if your data stores are in your data center, then you perhaps this would not suffice and you will need to create your own configuration. But you could use Terraforms or you could use Resource Manager. Exposure to Conda environment was also interesting. It's a package and environment management system. I have used PyEnv and other variations, but Conda seems like, if I'm pronouncing it correctly, it seems to be far lot isolated. That results in like fully separate configuration packages, tools, and that doesn't rely on your general system tools because a lot of compilation or a lot of module installation or instantiation that you do with PyEnv installation, not instantiation, it generally relies on your system tools. Now, OCI Data Science has this environment Explorer feature that provides you with Conda environments, and you can create your own, or you can publish and you can use their published environments, etc. Provides a lot of visual info sorting function. So I also learned a bit about libraries such as ONX or ONNX. I don't know how to say that. PyTorch, I've heard that so many times. I've never actually touched it, though, at least with this level of depth. And TensorFlow, and then like they also had there like a couple of slides talking about what are the use cases where you'll pick one over the other. And in some cases with ONNX, like the ability to switch from GPUs, like you choose different processor types and different architectures. So GPUs versus CPUs versus TPUs, and being able to switch between that. Now, ML lifecycle. This was intense, or included areas which just needed more time to be spent on, to be honest. Um, so before I took this cert, I had the exposure to feature exploration and engineering, and it kind of sounded simple because the AWS practitioner, AI practitioner that I did, I was like, oh, I'm pretty sure I actually understand feature engineering. No. So, like during this coursework, I got exposure to steps starting from pre-processing data, data imputation, um, outlier detection, the feature scaling, and like so many other aspects, which basically made me go through valley of despair about not knowing a lot in this space. Yeah, it was frightening. I think once when I was going through this, I had this feeling in my gut that the time I have given myself to do this cert is not going to suffice. Well, I was not wrong. Um, so ADS also had some really cool functions, and I think I'm gonna try to play a little more with ADS. So it had like functions for automated transformations, unless I'm thinking of some open source library, but I'm pretty anyway. So so that allowed you, person working on uh, the ML lifecycle, to essentially detect issues. You can visualize them, like, and then you can basically apply various optimizations to your data. Like auto transform was, I think, one of the functions there. Again, more work to do. So if you really know data science, please don't yell at me for staying at the surface level. Optimizations like dropping strongly correlated columns, which can have a pretty decent effect on the results that your model is going to produce, etc. Filling in missing values, dealing with noisy data, like mean, median, mode, using this where value is just either not present or invalid, etc. So there was a lot of new things, at least for me, as I was going through this coursework. One thing which I completely forgot to switch to. So, of course, I was using mind maps, talked about visualization capabilities. So there are there was AutoML. That was also quite interesting. So it uses model. Um, it uses its own model. I might not remember this correctly. It tries various hyperparameter configurations and basically provides you with a performance comparison. So it provides a lot of automation for steps that, as a data scientist, like you'll have to repeat, like ranging from feature selection to like which model or algorithm you should choose to for hyperparameter tuning, etc. So lots of customization if you want to, as an example, enforce a certain feature. Like there was an array in which if you really want to have certain features and not want those taken out by AutoML, you can basically provide that as an example. Then learned a bit about IDS Tuner, which was hyperparameter tuning framework. Seems to have search strategies and whatnot. I kind of just remember the names of what those search strategies were. I can't even remember how they are to be utilized at this point. So it works with, say, this ADS string tuner. This works with any ML library that doesn't have hyperparameter tuning. So you can basically generate a report with performing hyperparameter. With once you have tuned, you can perform reports in terms of hyperparameters and performance stats. I don't know what I said in the last line. So no clue how long this video has been. Now, with AWS AI Practitioner and other OCI certs that I have done before, like I said, I was fairly confident about like various metrics and like how supervised learning works, how unsupervised learning works, and like various categories or groupings in that, like regression versus classification and what metrics you want to use where. This had a lot more than what I originally thought. I really felt like I was lost, and as much confident as I was when I took on the coursework for the certification, I was feeling really challenged at that point. Now, a part of the pipeline, there was model explanation and interpretation. So it sounds pretty simple, but there was it was fairly dense. It talked about like plotting and visualizations and comparison of various features. And so it was a lot more dense than I initially thought. Even with the automated tools and workflows that comes with OCI data science. Then model catalog and model artifacts, you basically, so you get exposure to the files, you need to customize and run your models. There were a bunch of things that I did not even anticipate, like there were a bunch of files that you can essentially modify to tune how your model is going to run or it's going to behave at the start when you instantiate it. I'm pretty certain I'm using the wrong terminology. Then in the model deployment, touched on architecture and infra components, and I could breathe there. There were conversations about LVs, VM instance pools, auto scaling, etc., and basically performing deployments using UI, CLI, and ADS. It was a lot more complex because it also touched on a bunch of custom metrics that you can use for scaling or effectively maintaining the balance between performance and cost when running a model. Monitoring for drift, there was another part of ML ops that basically followed the deployments, etc. Because if you, depending on how effectively you have developed a model, the data that it's being developed using, it goes out of date, and also like depending on what type of inference you're performing and the quality of your model is, this is something that happens, like the drift basically happens. So then there was Apache Spark jobs. So there was a data flow service, which is a managed service, which allows you to run Apache Spark jobs. So Oracle basically tries to simplify, like with other cloud providers, democratizing these services, which would otherwise be really expensive for at least smaller businesses to build and run. That was it. If you've still managed to stick around, how? And thank you. With that, see ya.